So, this is my first stream, I guess. Uh, Using like this starter kit I got. Never used it before. I don't really know much about these, but I figured why not? Genuinely do think that it would help me in a few other things, but let's just open this up. Oh shit. Let's just get this. And I have opened it before, but well, yeah, there's like a bunch of stuff in here. Wait, no, that's not it. Yeah, here it is. Here's the main controller. Oh, there it is. Here's the thing. So, honestly, I'm just gonna go through like the PDF and see what I need to do. Add libraries and open serial monitor. Once you're comfortable using the Arduino software and using built-in functions, you may want to extend the ability of your Arduino and additional libraries. What are libraries? Libraries are a collection of code that makes it easier for you to connect to a sensor, display, module, etc. Okay. For example, the built-in liquid crystal library makes it easy to talk to character LCD displays. There are hundreds of additional libraries available on the internet for download. The built-in libraries and some of these additional libraries are listed in the reference. To use additional libraries, you need to install them. How to install a library? Using the library manager. To install a new library to your Arduino IDE, you can use the library manager. Scroll this to find it, then select the version of the library you want. Don't worry, it's normal. There are times we have to be patient with it, just as shown. Install a new library. You can now find a new library. You can even add your own. Selecting a port in which the serial monitor is the same as selecting a port for uploading Arduino code. Blink. Let's go. First one. First project. Well, technically, I guess. Don't really know. In this lesson, you will learn how to program your own Uno R3 controller board to blink the Arduino's built-in LED and how to download programs by basic steps. Component required, the ELEGOO. This LED is built onto the Uno R3 board and is often referred to as the L LED, how it is labeled on the board. You may find that your Uno R3 board's L LED already blinks when you connect it to a USB plug. Okay. The Arduino IDE includes a large collection of examples. Okay, basic. Okay. When the sketch window opens, enlarge it so you can see the entire sketch. Okay. The example sketches included with the Arduino IDE are read-only. That is, you can upload them to the Arduino board, but if you change them, you cannot save them as the same file. Attach your Arduino board to your computer with the USB cable and check that the board type and serial ports are set correctly. Arduino Uno serial monitor. Okay, note. The board and serial port here are not necessarily the same shown as the picture. If you're using 2560, then you have to choose the Mega 2560 as the board type. Other choices can be made in the same manner. And the serial port displayed for everyone is different. Despite COM626 shown here, it could be COM3 or COM4 on your computer. The right COM port is supposed to be COM-X, Arduino XXX, which is by the certification criteria. The Arduino IDE will show you the current settings for the board at the bottom of the window. Okay. Click on the upload button. Here it is. Blinking. If you watch the status of the IDE, you'll see progress bar with a series of messages. Next, the status will change up to uploading, transferred. Status will be done. The other message tells us that the sketch is using 928 bytes of the 32,256 bytes available. Interesting. Mine says 924. The sketch start with. Okay. Blinked. Wait, what? The sketch starts with. Okay. This example code is in public domain. Okay. The setup function runs once the press reset or power the board. Those are comments. Anything between dash and star dash is ignored by the Arduino completely. That is a block comment. Single line comments start with line, dash dash, and everything up until the end of the line is considered a comment. The first block of code is void setup. Okay. Initialize digital pin LED bulletin as an output pin model. Okay. Every Arduino sketch must have a setup function, and the place where you might want to add instructions of your own is between. I forgot what that symbol was, but eh. In this case, there's just one command there, which, as the comment states, tells us tells the Arduino board that we are going to use the LED pin as an output. Says setup. Yep. Unlike the setup function that only runs once, after a reset, the loop function will, after it has finished running its commands, immediately start again. The loop function runs over and over again forever. Digital write built in. Okay. High voltage level low. Okay. You're not going to make your LED blink faster, as you might have guessed. Changing the parameter. Okay. Period in milliseconds. So you want the LED to blink twice as fast. You change it from 1000 to 500. Okay. There you go. It's blinking twice as fast, I'd say. I don't know what this button does. In this lesson, you'll learn how to change the brightness of an LED by using the different values of the resistor. Okay, so it says I need the Arduino board. I also need, it says a 5mm red LED. Well, first of all, I need to find the goddamn breadboard. There it is. No idea what any of these are. Solid or this? Okay. Oh, they're in here. What the heck is this? What are these? Oh, these are the male to female wires. Why are they so organized? These are so organized, meanwhile these are just bundled. Okay, so got the breadboard, the resistors, I got the wires. Should probably put this over here. And I need the, what were they? The one red LED. Here we go. Okay, that's all we need, right? Okay. Let's put this back. Need some of these, so. Okay, I'll just close this for now. Okay. 120, 220 ohm. Also, it's very inconvenient that they didn't put all these in their own bags, but rather just stuck them all on the same bun, in the same one. 220, here we go. There's a lot of that, Jesus. Yeah, sorry about that. There's a lot of angry people outside. Anyway. Hold on, excuse me. Man, I don't usually talk this long. It's worth it. I need to learn all this. Okay. Now what? Oh wait, no, I need the other ones. 1K. That's 1 mega. 100K, 10K. I need 1K. Put these in order. And 1 to 20. These are made to be cut, as you could tell. Also, this one's a little bit more flimsy than the other ones, but eh. And it's like one of those bags drug dealers use. I swear it's not drugs, it's just resistors. Okay. Switch over to the PDF, because I already have this. Well, I mean, how many wires actually do we need? Just 2. Okay. Trying to stay organized here, so I don't lose my mind. Okay, let's set those aside. Okay. I feel like we could switch over to the PDF now. Alright. I forgot to take out the breadboard, but I show that real quick. Oh shit. Okay. Just the breadboard. Breadboards comes in various sizes and configurations. The simple kind is a grid with holes in a plastic block. Inside are strips of metal that provide electrical connection. I mean, I know this. LEDs. Oh, yeah, there's a positive and negative side. Positive, negative, okay. If you do not use the resistor with the LED, it may well be destroyed almost immediately, as too much current will flow, heating it and destroying the junction where the light is produced. There are 2 ways to tell which is the positive lead of the LED, which is negative. Firstly, positive is longer. Secondly, there's a negative lead enters the body of the LED, where there's a flat edge to the case. flat edge to the case. As the name it suggests, resistors resist the flow of electricity. The higher the value of the resistor, the more it resists and less electrical current will flow through it. Yes, I know this. But first, more about resistors. Ohms, yes. Kilo ohms, mega ohms, yes. We're going to be using these three. Okay. These stripes will tell you the value. Okay. 5-byte code. The one on top of the bulb is the actual, like, variability of it. I mean, I don't necessarily have to remember this, but it's nice to know. To keep track easily, just by looking at them. Okay, connection 5 volts into the 220, and then connection into the LED. From positive to negative. So I got my 20 ohm resistor. Let's show this real quick. So I'm gonna go from red to one of the points with 5 volts. 5 volts. Oh shit, the shake is a lot more noticeable on this. 5 volts here. As you can see. Right there, 5 volts. Okay. I guess that works. And ground to, well, negative because, well, it's ground. And these do not want to get stabbed. Okay, that works. I'll just put it over here. I'll just put it right there. I don't want to bend these too much. Then what? From positive to negative. So from, can I actually like split these apart a little bit. I don't know if that will. It'd have been just easier if I would just do this. Go from power and to just like onto like one of these offshoots, like right there, so I could just easily jump from oh shit. That's positive. Okay. I still don't know which one is which other than like the length. So I have to like bring them together to figure out because that's positive. Positive to, no, not positive. Positive to negative. Positive to negative. There you go. How's that? LED resistor. Boom. The Uno is a convenient source of 5 volts, which we use to provide power to the LED. You do not need anything to do anything with your Uno except plug it into a USB cable. So I got this power bank. Let me just press it on real quick. Let me set it on low voltage so it doesn't blow the fuck up. Hey, just look at that. Oh, it still blinks. Oh, that's cool. So you don't need the... That's cool. Alright. Nifty. Also, this weird angle. Weird angle. This still blinks. Still blinks. Weird. What if I have? What happens if I do this? Still doesn't. Interesting. I wonder what happened if I just unplug it. Look at that. What if I just plug it without the low setting? Still 5 volts. Oh! Oh shit. I mean, I pressed it again, but is it too much? Yeah, it's too much. Oh, let me unplug it. Yeah, I have to put it on low voltage setting for this battery. Yeah, look at that. It's still cool. Also, I don't know if that damaged anything. What I'm gonna assume, and the next step is just to switch out the resistor, and let's just get less current, which will dim it a little bit. So that's what I'm just gonna assume. Okay, let's see what the PDF says. The Uno is a convenient source. Hold on. I'll just have this floating around, I guess. Okay, I already read that. With the 220 ohm resistor in place, the LED should be quite bright. If you swap out the yep, there you go, swap it out. For the 1K resistor, then LED will appear a little dimmer. Finally, with the 10K resistor in place, the LED will just be about visible. Pull the red jumper lead out of the breadboard and touch it into the hole. And remove it. Wait, what? Pull the red jumper out of the breadboard and touch it into the hole and remove it so it acts like a switch. Oh shit, that does. I mean, that makes sense. Just cutting off a connection. It's why am I being so surprised? It's literally just like all this shit I already knew technically. Okay, let's see what it does. I mean, it's pretty obvious what it's gonna do. It's pretty obvious. So hold on, let me just unplug this. Nifty anchor. I mean, it wasn't really meant for that. It was really meant for my phone up here. All right, let's just switch out the resistor. Straighten this out. Straighten this out. There you go. And this should be the 1K. If only I had like a multimeter, I should probably get one of those. Let's do one of these. There you go. One of those. And connect this here, and then connect it here. Bada bing, bada boom. Look at that. Let's plug this in now. Ah, look at that. It's a little dimmer. And also, this is funky. Man. Let's just flip this over. There you go. There you go. Hopefully it's not on the... Yeah, okay, it's on low voltage. There you go, there you go. It even acts like a switch if I just touch the hole. And it's even dimmer if I put in the 3.3 volt one. I don't know if you're able to tell. Probably definitely gonna be able to tell like after the 1K one. There you go. Hit it with one of these. Put it in here. Put it in here. Shaboom. Boom. Yeah, look at that. It's a lot dimmer. A lot dimmer. I don't know if I should zoom this in. Probably. Look at that. It's a lot dimmer. Look at that. What I can do is set up a little thing between two different things for which one I want to use, but to showcase actually showcase like the actual difference between them. But that means taking up more wire, and that's annoying. So what I can do is just line them up. So I can just line them up and just switch between them real quick. What is this one? This is the 220. So one end is not about the same. I'm gonna go buy them all. I'm gonna put these over. Put one over here. Yeah, I can reach. Of course, it can reach. This one's the 220. Okay, that's the first one. Look at that. Look how bright it is. Set this one over here. But if we put it in parallel, that's bad. Because it would just only allow more current. But it's still relative to like the 220, so that's fine. So, that's the 220. Oh shit. That's the 220. This is this is the 10K, and this is a 1K. So I'm just gonna switch them out real like a little bit to showcase the difference. That was the 220. This is the 1000. Okay. And this, hold on. This is a 10K. Look at that, a lot dimmer. It's hard to see because of the camera quality, but still. Kind of neat. Kind of messy. See if I can just push this up real quick a little bit. Yeah, it's fine. Look at that. 10K right there. You could also line them all up in series. So say I could start over here. Push it all the way over here. Oh shit. There you go. I believe that was the 220. Yeah, this one is the 1000. So I could just go from this node to a different node over here. And then starting from that node, you can then go from there to the node on the LED. Look at that, ton more dimmer. It's barely even on. Even less on if I were to take this on and put in the 3-volt one. Look at that, barely even visible. Oh shit. Look at that, barely even visible. Not even showing pretty much on camera. Let's go back to 5. See a little bit. Okay, so project what, 3? 3? That was project 3? Yeah, it's project 3. It's cool. Simple. I mean, this one's pretty much just a simple circuit. It's not really anything to do with like coding it's at all, but it's still cool. It's still cool. Like I get how resistors and all that works, capacitors. Well, I don't know. Capacitors are a rough spot for me. Inductors too, even though they're like the main part. Like I know how to do math with them, like using all those properties and stuff, Laplace transform, phasor domain, stuff like that. But stuff like this, I don't know. Like related to like things like this. Lesson 4. Let's go. RGB LED. RGB LEDs are a fun and easy way to add some color to your projects. Since they are like 3 regular LEDs in one, how to use and connect them is not much different. 2 versions, common anode and common cathode. Common anode uses 5 volts on the common pin, while the common cathode connects to ground. As any LED, we need to connect some resistors in line, 3 total, so you can limit the current being drawn. In our sketch, we will start with the LED in the red color state, then fade to green, and then fade to blue, and finally back to the red. By doing this, we will cycle through most of our color that can be achieved. Let's get a green one. And a blue one. Let's open this thing again. Put this one back. Oh, those are white. I think it is these. Oh shit. Yeah, I think it's this one. More resistors. Man, now I gotta lay him out again. Oh man. Oh, this one's bad. I think I could put these back into their place. Maybe. I'll keep this out. At first glance, RGB, red, green, and blue LEDs look just like regular LEDs. However, inside the usual LED package, there are actually 3 LEDs. One red, one green, and yes, one blue. By controlling the brightness of each of the individual LEDs, you can mix pretty much any color you want. We mix colors the same way you mix paint on a palette, by adjusting the brightness of each of the 3 LEDs. The hard way to do this would be to use different value resistors, or variable resistors, as we did in lesson 2. But that's a lot of work. Unfortunately for us, the UNO R3 board has an analog write function that you can use with pins marked with a squiggly line to output a variable amount of power to the appropriate LEDs. The RGB has 4 leads. There's one lead going to the positive connection of each of the single LEDs within the package, and a single lead that is connected to all wait, to all three negative sides of the LED. I'm assuming the cathode. Okay, that's how it looks as a circuit. Typically, the longest one is the cathode, I believe. I think that's what it was doing. And to the side of that is the red. Here in the photographs, you can see 4 electrode LED. Every separate pin for green or blue or red is called an anode. You will always connect positive to it. Cathode goes to ground. If you connect it the other way around, the LED will not light. The common negative connection of the LED package is the second pin from the flat side. It is also the longest of the 4 leads and will be connected to ground. Each LED inside the package requires its own 220 ohm resistor to prevent too much current flowing through it. The 3 positive leads of the LEDs, one red, one green, and one blue, are connected to UNO output pins using these resistors. The reason you can mix any color you like, but okay, this is just color theory. I understand this. Theory: pulse width modulation is a technique for controlling power. We also use it here to control brightness of each of the LEDs. The diagram below shows the signal from one of the PWM pins onto the UNO. 5%, 50%, 90%. So it's still the same. It's still the same voltage peak. It's just that the intervals are differ, or like how long it's on for differs, which changes how we perceive how bright it is. So the more it pulses, or the longer it stays on in an interval, like the 90% here, the brighter we see it. Because 90% of the time, I guess, no. Yeah, because 90% of the time it is on. So roughly every 1/500th of a second, the pulse width modulation output produces a pulse. The length of this pulse is controlled by the analog write function. So analog write 0 will not produce any pulse at all, and analog write 255 will produce a pulse that lasts all the way until the next pulse is due. So that the output is actually all all. Wait, what? So that the output is actually on all the time. Wow, I can't English. If you specify a value in the analog write that is somewhere between 0 and 225, then we will produce a pulse. If the output pulse is only high for 5% of the time, then whatever we are driving will only receive 5% of the full power. If, however, the output is at 5% for 90% of the time, then the load will get 90% of the power delivered to it. We cannot see LEDs turning on and off at that speed, so to us it just looks like the brightness is changing. Yeah, that's what I was. Yeah. Okay. I'm using the top part now. Let's set it up. Set it up. Okay. So it says to have it like this. Should put the resistors in first. I mean, it's not really necessary to like specify, but should probably do like one of these. Yep. Bruh. Need 2 big hands. I'll space it out because I mean actually I don't even know if I could space them out. Let's back this up real quick. Zoom in a little bit. I think that's fine. I mean, it doesn't really matter the order of them, but just because it looks better. There we go. Now each wire, this one specifies 6. No, green, need 5. And blue going in squiggly 3. Okay. Moves a lot, but sure. And the black one has to go into ground. This will be the cathode. Well, for the cathode. This one will be closer. Okay, so I guess that's just how it's gonna be. Okay, now the LED. This one is the cathode. Okay, so it's supposed to go like this. Here, here, and here. There you go. Hopefully there's enough contact in all these. Okay. So now what? After wiring, please open the sketch. Sketch starts by specifying which pins are going to be used. Alright, let me connect this then. So I can overwrite it, and then I believe I could just power it. Okay, let's upload it. Now if I take this out and just plug it in to my power bank, I feel like, since the thing is right there anyway, I feel like it should work. Yeah, nice. Now, let's change. I'm definitely gonna have to purchase a longer cable because this is not it. Okay, now let's do 150 across the board. Nah, let's do 150, 50, and 255. Sure. Ooh, that's a nice purple. Check that out. Hold on. That is a nice purple. Look at that. Look at that. Hold on. If I take this out, yep, doesn't work. Look at that. Look at that. Oh, that's cool. I don't know why the LED there is still on. If I take out the blue, ah, look at that. Now it's like an orange. Well, not really. It's more like yellow. If I take out the red, even more blue. If I take out the green, oh, look at that. Oh, it's weird. Probably because it's not a lot of green. That's very nice. Very nice. If I take out both of them, it's just green. Take out red and green, just blue. Take out green and blue, it's just red. And if I set all of these to, I believe the same one. If I set all these to like 150, I believe it should just be white. You just go plug it in real quick. And let me just upload it. Yeah, it is. Yeah, check this out. Let me plug it in. Look at that, white light. Take one out. Ooh, yellow. Take this one out. Boom. It's weird. And take this one out. Purple. Well, more magenta. It's more like magenta. But all three of these? Oh my goodness. I just realized something. It's kind of like the thing. Kind of like that one thing. Yeah, hold on. Let me show this. Yeah, it's kind of like this. Look at that. All three of them make white. And if you take one out, it's cyan. Cyan. Take out the green. And you get magenta. You take out the blue. And you get yellow. Look at that. Well, it's a little bit more green, sort of looking. All three of them white. Look at that. Well, that's lesson 4. I'm gonna go ahead and wrap up this stream for now, cause well, I ran out of time. It's already kinda getting late, and I need to do other things. So, well, if anyone's out there, thank you for watching. And well, if you are on YouTube, hi, I guess. Hi. I don't know. It's first time doing this, so I don't know. Tell me what you think. How I did. I don't really know. It's all kind of new to me, so hope you enjoyed. And bye.